Hi again. So in the last video we talked about the for loop, and we are getting somewhere. You are in school studying probably computer science, some academic professional education. So you've probably been reading in your book since the last time, and you're watching this video because I'm gonna help you just get the last thing, some of the more school correct answers. So what I'm gonna say is that I think it's about time that we introduced another class to talk more about object orientation. So let's go ahead and clean out all this, basically delete what we had before, and I'm also gonna clean this. And the reason for that is that in the start, you remember we talked about the main method. This is where the program starts. And in ideal situation or scenario, I guess most would probably agree that, and this most would probably agree that you only have a few less, the less the better code in the main as possible, because that is where your program starts. So let's go ahead and create another class. Well, we have our first class here, which is this file, and let's talk about conventions in Java for now, before we create the new class. Pay attention to the word public here. The word public is appended, well, put in front of, or some would say in the back, before the word class, if the name of the class is the one that's also sharing name with the file. So if the file name is first class, you only, and just one of them can be public. You can of course write another class inside this file, it doesn't really, you can test and just like do this, you have another class, sure, but you cannot have it public. If I spell it correctly, it will be better. You will also see that it's complaining as a class test is public, should be declared in a file name test.java, which is exactly what I'm saying, is that you have to have public on the class that have the same name as a file. It's a Java convention. And the top we have the imports of things we were using, and I'm just going to delete that as well. Let's go ahead and right click and sort here and create a new Java class, and let's call it second class. Inside the second class, we're gonna not create a main, because why do you think that is? I guess you probably told it the right way, or guessed the right way, because the main method is where your program starts, so you only need one main. So what you're gonna do here in this class is to create a public method that is not returning anything void. You give it a name and you call it second, with small second, class method _1. Horrible name, but it works. And you're gonna print out to the screen, this method is called. So our interest is to call this method here, that's called second class method 1. And what this method is doing is not really important for this lecture at all, but what you can do now is say, well, can I do second class dot? No, you cannot do that. When you're working with objects in a programming language, think about as this is an object, this is a class, and it's a blueprint, which basically means that you need to build it. Just like if you're in a construction work, so you're working with cranes and holes in the dirt and stuff like that. I know it sounds not that sexy with holes in the dirt, but you know what I mean, right? Then you have this blueprint of how the building should look. You're looking at it, and you're looking at it right now. I even marked all of it to make it blue for you to like, oh, it is a blueprint. But what's different is that it's something you write, and when you write it and you're actually building it, you still write, but in the real world you have it on a piece of paper and you build it with machines and hands and people, and then it's actually being manifested in around you, and so it's physical. The problem, code is not physical, but the same kind of thing as the physical build-up would be called something different in a code world, and that is called instantiation. So we're going to instantiate this class here called second class. The way we're going to do it is say second class, and remember type name equal sign assignment from before and semicolon. That is the syntax. So the type of variable we're going to create to hold this new instantiated class, the physical representation in real world, that would be second class, because that is the type of variable we're going to create that's going to hold this instantiated second class. So it is second class type. Everything in Java is a type, mostly. Class is a type, so the type name is called SC, just to make it easy. And then write new, because we create a new one, second class, and end that up with parentheses, and that's it. Now we can go ahead and say sc dot and call the method here and run the code one more time, and now we'll see in the below console that second class method 1 is called. This is how you call a method, and from another class. Pay attention to another thing that changed. Can you spot the change if this is where the change is? You probably guessed it correctly. The static keyword is now gone, and that is something we talked about in the past, some of the videos. If something is static, it is available for the context of wherever it's being called. Also, it is pre-instantiated. Now we just instantiated here our class second class in order to call this, because it is not static. If I go ahead and say, what if I add the word static here? Okay, so we can do that, but we can also remove this, and instead of this, say second class, and run the code. And now one more time you will see the same output, because you are just calling a pre-instantiated available in this context because it is public, and then you just call it. But that is not beautiful code. This is horrible in a way to code things statically. So I wouldn't say and recommend this way. Of course, static is not a keyword that is illegal. However, as a new computer science student, you should definitely learn that you want to avoid the staticness, and as much as possible go ahead for the instantiated stuff. So now that we can instantiate a class, let's talk about what is this way of programming called, because it do have names, and your teacher might even ask you about this. So let's talk about it. This is a class variable, or just a variable. It is by the type of second class because we named the class second class. So now that is a type, basically the type of what's inside. So what is defining a type really? Is it the name or is it the content? Now, by having many hours of programming on my back, it is the methods inside of the class that's actually defining the content of the type. So if you were to add another method in this type called second class, then of course it would change the type to have another method. But you should not change this because you're using the same type. Now there are other things we could talk about in another video called interfaces, which is basically how we're gonna escape all this type to type. You know, we have to have second class and a second class and stuff. If you are already a bit ahead, you might think, but having a variable to only one type, isn't that a bit strict and narrow? And yeah, it is, you know, but it's not wrong. It's a part of the language, and sometimes it is the way to go. Other times you need to have a little more, let me call it a loose coupling, to hint a word now, which basically will mean that you have a variable that's uniform to whatever stuff you put inside of it, and you can create that in Java. But for now, in this video, I'm not gonna cover that because it's gonna get too much. So now that we can call a method, we also need to learn about something called fields or class variables, or whatever we're gonna call them. So inside the second class, I'm gonna go ahead and create a private, and now we're gonna use the word private, a private string called name. I'm also gonna create a private integer called age, and now we're gonna learn about how can we access these two, name and age. The first try will probably be to say sc.age, but you cannot even see it, so IntelliJ is helping you. The way for you to work with the two variables here is to create some public methods that are going to work with the variables. And now I'm going to say, why is that important? Well, it is because when you have a method that can work with a variable, you can have multiple of lines to help you verify stuff. Let's create the method for the public void setAge, and whenever you use the word set or get in front of a method name, it is usually referred to as getters and setters, because setters set values and getters get values. That's the way it is. So as we also talked about, the input would be int, let's just call it temp age, and then we need to access this variable called age. And in order for us to make sure that it is second class variable age we're accessing, we're using the keyword accessifier called this age, and this refers to this class we're in. So whenever the interpreter is reading this Java code, is saying, okay, so we have the overall wrapper, which is the class. Inside of that we have a word this, so this is second class dot age. We're going to set that equal to temp age. That is really a setter's job. Now what you might think here is, but can I then do age minus 5,000? Can I set age to 500? I wouldn't say that any humans can be at negative age. Any humans cannot be 5,000 years old. So let's say that if you only had a variable, raw variable, and you make this public, you could easily just set it to any value you would like to. That is of course pure nonsense, and you should avoid the kind of things, which is why you're creating your variables or your fields, what you're going to call them, class variables, as private, and you're going to create methods to work with the values. We're also going to need to a way to get the values. So let's say public int get age, just like this, and then we're gonna return this age. Basically that's it. So we're having a public method. It's returning an integer because age is an integer, so we need to fix the type. This is also type, and basically returning this age. So now I can go back to my program and say, no need to call the second class method 1. Let's set age to 50, and let's print out get age and run the code. And now you can see that what I'm getting back is the number 50. But could I say minus 50 here and run the code again? And unfortunately we haven't created the code, which is why we're gonna make the example right now and go and fix it. So we have this set age here, and what we should do is basically have some sort of condition asking if temp age is less than 0, then it would be not less than 0. Whoops. I am used to, let me see. Yeah, we cannot do that in Java. So we're saying if it's, this is another example of having conditions. If it sounds weird one way, flip it around, say it have to be larger than 0. Okay, and the temp age have to be less than, let's assume the maximum human age for now is 140. No one have been that been that old, but let's assume this is the way. Then we're gonna set the age. Else, basically, we're gonna do an output statement in the else we talked about in the conditionals video, and basically say your age is either too low or too high. Let's go ahead and run the code again. We had before, we had -50. We're gonna run this, and it's basically say your age is either too low or too high, and we get a 0 because 0 is the instantiated value of the integer value. Let's go ahead and write 11. Your age is 11 now. Let's write 141, which is 1 higher than the maximum amount we allow, and now again we are not able to do it. So we are creating some sort of filter going on in the back screen. So we are using the method called setAge as a setter type to actually verify that the user doesn't do any stupid mistakes. This is called abstraction, which is another part of object-oriented programming, that you are using another class and you're calling its method. So whenever you call the method setAge, you have no idea what you're really calling in the behind the scene. All of this is being executed. So this is called abstraction, so not really have to worry about what's inside of this class. Now we also covered getters and setters. We covered new classes. We covered private keywords. You can also have private methods, which is, of course, sometimes you do a private something method, a method. Let's just call it test for now. And then sometimes you need to do something like this. You need to call the method inside your other method in the same class, because this is doing some important job, but because you're doing it a lot inside of the same class, you are creating a method to avoid redundant code, to avoid to having the same code present in the same class too many times, which is bad in object-oriented programming. So I think for this video we're gonna cut it off. In the next video we're gonna talk about a bit more about object-oriented principles. We're gonna introduce interfaces, and I think we're gonna wrap up and say that's it for the quick and dirty injection of object-oriented Java programming for AP, academic professional educations, or early bird, computer science student that already have access to material. Take care.